stoichiometry. So you've gone through all the material on writing equations, writing ionic equations. We've also gone through the mole concepts, so now we're going to marry these concepts. I'm going to try to keep these videos 10-15 minutes. This set of slides is going to be 2 videos. All right, and again, there's a lot of opportunity here for you to try problems, so while you're watching the video, you should have the PowerPoint up so you can pause the video and go back and forth as necessary. Also, there's a lot of times where I'll say, here's something, do this step. Make sure you hit pause on the video and try it for yourself as you're going along. The textbook does a good job with this material. This is in chapter 8 of the book. All right, so let's get started. Stoichiometry is the how much. Right, so like I said, it's the math part of chemical equations where we're going to marry the mole concept. So this is what it is, all right? And you can use the balanced chemical equation to predict amounts of reactants and products, right? And if A reacts with B, how much of A is necessary to get B, and how much of B comes from how much A, exactly, right? So just to give you a feel for this, right, a balanced chemical equation is the ratio. So this is the reaction of hydrogen and nitrogen to make ammonia. And you can see we've talked about this before in terms of balancing equations, how matter is conserved. There are 6 hydrogens, atoms on this side, 3 molecules. And there's still 1, 2, 3, 4, 5, 6 hydrogens, 2 nitrogens, right? So we can express this as being 3 hydrogen molecules reacts with a nitrogen molecule to form 2 ammonia molecules. But the ratio is good no matter how much, so we could also do this in moles. So 3 moles of hydrogen react with a mole of nitrogen to form 2 moles of ammonia. And of course, once something is in moles, from moles you can get mass, you can get particles, all sorts of stuff like that. Right? So just for a generic chemical equation, you can think of, we've used the analogy all semester of solving a problem is like taking a trip. So if you're going to take a trip, maybe you get on the highway. So if we look at a generic chemical equation where A, B, C, and D are the reactants and products respectively, and then P and Q, are the coefficients. All right, so we can read this, M moles of A reacts with N moles of B to form P moles of C and Q moles of D, right? And again, that previous equation was a specific example of the previous slide. All right, so like I said, that means this is a mole ratio. So 3 moles, 1 mole, 2 moles. So that means if I wanted to go from moles of nitrogen and find out how many moles of ammonia I would produce, I would take the moles of nitrogen, I would use the ratio, and I just use the coefficients. There's 2 moles of ammonia for 1 mole of nitrogen. In general, as we've said before in chemical equations, we don't bother to write a 1, it's understood. So if I had 3 moles of nitrogen, how much ammonia could I get? Well, I would say 3 moles of nitrogen. There's 2 moles of ammonia for every mole of nitrogen from the balanced equation. And so I would get 6 moles of ammonia. So the idea is that the stoichiometry part, the balanced chemical equation, is a mole-mole conversion. Now you've done mole-mole conversions before, right, in context of chemical formulas. Chemical formulas are mole ratios as well. So like I said, let's think of it as, and again, you've seen my handwriting, think of the balanced chemical equation as being like a highway. So the idea of solving a problem is like taking a trip to someplace you've never gone. So if these are grams or particles, the on-ramps are converting to moles. This is all moles. So you have to first get to moles, then we use the balanced chemical equation to get to moles of something else, and then we would use to get out of moles. So the off-ramps would be getting from moles, right? Which is basically what this slide says. So on-ramps and off-ramps are conversions. So as a review, I would go back and look at the material for homework 4 before we went online, before the pandemic. Right, we did a lot of this in class. Homework 4, your last test was over this material. Right, so remember, you can go from particles to and from moles using Avogadro's number, and multiplying or dividing depends on which way you're going. Avogadro's number has moles in the denominator. To go from mass to or from moles, we would use the molar mass. And remember, the units of molar mass are grams per mole. So these are the on-ramps and off-ramps. So how do you get to moles? It depends on what you're told. How do you get out of moles? It depends on what you're asked. If you're told particles, you would use Avogadro's number, or if you're asked about particles. Okay, mass, you would use molar mass. So for example, looking at this diagram again, if I wanted to go from the mass of A to the mass of D, so the mass of A, first I have to get to moles. So I would go use the molar mass of A to go from grams of A to moles of A. And you've done a lot of these types of calculations. Then I would use the balanced chemical equation to go from moles of A to moles of D. And in this case, there are m moles of A for q moles of D. Right? Then once I'm in moles of D, I would get out, and since I'm going to mass, I would use the molar mass of D. Okay? So that's the idea. What's one way or another, we're going to get to moles, then we're going to use the chemical equation to get to moles of something else, then we're going to get out of moles. Again, just another example, if I wanted to go from particles of B to the mass of A, and you can go anywhere you want. You can go this way, this way. So again, if I was going to go particles of B, atoms, molecules, depending on what B is, I'm going to use Avogadro's number to get to moles. Then I'm going to use the chemical equation. I would have n moles of B for m moles of A. Okay, on the top or on the bottom is going to depend on the units. Then to get to grams of A, I'm going to use the molar mass of A. All right. So you should be comfortable getting to and from moles. You should be able to do it in your sleep because we did a lot of that stuff on homework 4 and in a lab and in the last exam. Okay, we've done mole-mole conversions before, but we didn't do it with equations. We did stuff like how many moles of chlorine in a mole of AlCl3, right? And remember, just to remind you, there's 3 moles of Cl. The only new thing is using a chemical equation as a mole ratio, but it's very straightforward. You literally just copy the coefficients right off the balanced chemical equation. And then this is a good place where you're going to use a lot of dimensional analysis. So all the skills that we've been working on all semester about using dimensional analysis. So make sure you write your units clearly. Write down the units of the answer right away. Make sure you don't just write moles, but moles of what. Don't just write grams, but grams of what. And you'll see why. All right? Right? As we do more of this, you're going to find all stoichiometry is a variation on the theme below. One way or another, you're going to be given a starting question, starting number, and you're going to have to get to moles. Right now, you would use molar mass or Avogadro's number. Later on, you'll use a couple other things. We'll talk about that when we get there. Then you'll use the balanced equation to get to the moles of what you're being asked about, and that's where you use the coefficients. And then you're going to go from moles of what you're asked about to what you were asked. So if I'm in moles of D, right, then I'm going to have to get out of moles. I would again use molar mass or Avogadro's number. All right, so I'm going to pause this here, and we'll pick up here on the next video.